Hi y'all, in this video we'll continue with the notes from day 19. In example 5, we're told a set of data items is normally distributed with a mean of 400 and a standard deviation of 50. We want to convert each item to a z-score. To reiterate, a z-score is really just the number of standard deviations away from the mean. And it's a signed number. What that means is that if it's positive, it's going to be bigger than the mean, and if it's negative, it'll be less than the mean. So the z-score for 450, we're always going to take the data item, in this case 450, minus the mean, in this case 400, and divide it by the standard deviation. So it should work out to be 50 over 50, or 1. So we would say 450 has a z-score of 1, it's 1 standard deviation above the mean. 325, the z-score for this, well, since it's less than 400, it should be negative, and we're going to see that in the work. But 325 minus 400 over 50 is a negative 75 over 50, or a negative 1.5. Alright, 400. Well, probably figured this out already. Let's work this out. 400 minus 400 over 50. That's a z-score of 0. 400 is 0 away from 400. And 490, well, the z-score there should be 490 minus 400 over 50, which would be 90 over 50, which is 1.8. So 490 is 1.8 standard deviations above 400. In example 6, we're told that yearly returns on a large company stocks, at least for this purposes of this exercise, are normally distributed with mean yearly interest of 14.7, or mean yearly return of 14.7%, and a standard deviation of 19.5%. We're asked to find the z-score for an investment that earns 34.2% annually. Well, here we're told the data item, and we're asked to find the z-score. So again, the z-scores here should be 34.2 minus 14.7, that was the mean, over 19.5. That looks like 1 to me. In B, we're told the investment earns 55.65, so that's our data item, 55.65 minus the initial mean of 14.7. We're going to divide that by 19.5. Working that out in the numerator with my handy dandy little calculator, 55.65 minus 14.7 gives me 40.95 divided by 19.5 should be 2.1. Alright, in C we see something interesting here. Here we're told that the investment loses 14.55, so we'll be a little careful here. We want to have a negative 14.5, and from that we'll subtract 14.7. There's no problem at all with having negative values with this. And divide that by 19.5. Should be a negative 29.25. Divide that by 19.5. That gives us 1.5. Negative 1.5. So a negative 14.55 return is 1.5 standard deviations below the mean. This very last one, again, the z-score of negative 1.05 minus 14.7 divided by 19.5. Let's see, that's a negative 15.75 divided by 19.5. That should be about 0.807. Negative 0.808 or so. In example 7, we're told a set of data items is normally distributed with a mean of 25 and a standard deviation of 4. We're asked to find the data item in this distribution that corresponds to the given z-scores. Well, in general, let's put the formula over here. We know the z-score equals the data item minus the mean over the standard deviation. If I care about finding what the actual data item is, I can multiply the z-score times the standard deviation and then add the mean to both sides. So the z-score should be the mean plus, rather the data item should be the mean plus the z-score times the standard deviation. So looking at A, if I want the data item that's 2.1 standard deviations below 25, that item would be 25 plus a negative 2.1 times 4, which is 25, plus minus 8.4, which is 16.6. In B, 25 plus 3.2 times 4, we're going to get, that's 25 plus 12.8, should be 37.8. C, 0.6 standard deviations below the mean, should work out to be 22.6, and D, 25 plus 1.7 times 4 should give me 25 plus 6.8, which is 31.8 or so. In example 8, we're asked to find the percentage of data items in a normal distribution that lie below z-score of negative 1.3. So we can draw our little curve here. Point out that a z-score of negative 1.3, that would be right here, negative 1.3, and we're talking about this right here. Now what we're going to find is this is exactly what the curve we're going to care about is going to tell us. So let's pull it up real quick. Looking at our z-score table and looking for 1.3, which is down toward the right, we should see that says 9.68. So back in our question, we see we're looking for the percent of data items that lie below a z-score of negative 1.3. This should be 9.68%. Again, that's on your z-score table in the day 19 notes. In B, we're asked to find the percent of data items that lie above a z-score of a negative 0.3. So I'm looking for this amount over here. I can go over and I can look at the z-score table for a negative 0.3 and see that a negative 0.3 z-score right there is 38.21. Well, coming back over here, looking at the notes, what that's telling me is that this amount right here, over to the left, below negative 0.3 is 38.21, which is going to tell us the part I care about here, in black, is not 38.21. In particular, what I know is this whole area under the curve is 100%. So that's the black area should be 100% minus 38.21. It's what's left here, or 61.79%. Going to example C. This is going to involve me drawing several different pictures here, so I'm going to start over here. The answer to the question I actually care about, I want to find the area that lies between negative 1.4, standard deviations below the mean, and 2 standard deviations above the mean. So this is the picture I care about. But when I come over to my z-score table, I only ever can get pictures that look in this form. While I'm here, I'll look at the negative 1.4, and I should see that 8.08% lie below the mean there. The 2, 97.72% of the data items lie below 2 standard deviations below the mean, which is going to tell me that if I look at the following couple of pictures, now you're welcome to draw better pictures than this, but right there, that amount should be 8.808% or so of the data items. And this amount here should be 97.72% of the data items. And what I'm wanting to do is to find a way to get at just the part in between them, this right here. That's the thing I'm going to care about. And what most of you may see right now already is that to find the amount between them, I'm just going to subtract them. 97.72 minus 8.08 gives me 89.64% of the data items should lie in here. And that's what I want there. A similar idea there with the last problem. Same basic idea. On D, between 1.1 and 1.4, this amount here, I'm going to look up the value in the z-score table for 1.4. I'm pretty sure I'll do that in a second. And I'm going to look up the value for 1.1 and just subtract them. So the 1.4 value should be 91.92. The 1.1 value, 86.43. So what I'm going to do with that again, I'm going to take that 91.92 minus 86.43, and I could draw out a few more pictures to see that, but that's exactly what I'm going to want. And that should be 5.49% or so.